Welcome to my work solutions for the WJEC, also known as Eduqas, past paper. It's component one as they call it, paper one to everyone else, which means non-calculator. And as you can see, we're looking at the November 2023 series. It's 2 hours 15. Let's see how long it takes us. So question one, where do you kick off? But just going from a ratio to a fraction is the first thing. How much pineapple? Pineapple is the middle share. That's 2 out of 7 plus 2 plus 1. 2 out of 10 of the shares are the pineapple juice. Ivy has 330 mils. Well, we can work out 1/10 by dividing by 10. So we know what 2/10 are worth by doubling it. And there we go for our 2-mark starter. Number 2, we've got a strange looking cloverleafish type shape. Work out the area, give your answer in that form. So no need to muck around with decimals. The diameter of each semicircle is 12. Now if the diameter is 12, that's also the length and the width of the square in the middle. Your first job, earn the easy mark. Work out the area of the square, and that'll form part of your answer. The bit that's trickier is you've got these 4 semicircles, but 4 semicircles means 2 circles. 2 times circles will be 2 lots, and the formula for the area of a circle, pi times the radius squared. Be careful, it's the diameter, which is 12. Area uses radius, which is 6. And we're asked to leave it in terms of pi. So we only need to work out the 2 times the 6 squared. 2 times 36 gives us 72 pi for our answer. Number 3, block of stainless steel. When you see words like volume, density, you should be straight away writing down your DMV triangle as your starting point. The block has mass, so we're trying to work out the mass. That leaves us with density times volume. We've got the density of 7.5. We've got the volume of 700. You can work that out your own way. I'll just stick with doing 7.5. I'll times it by 7. 7 5s are 35. 7 7s, 49. Add on the 3. And if there's one number after the decimal point in the question, there should be 1 in the answer. But obviously that's times in by 7. I need to multiply by 700. So let's jump the decimal point once. That's times by 10. And again. And that's in grams. It wants you to compare it to 5 kilograms. So you should either be changing the 5 kilograms into grams, or this 5,250 grams into kilograms. His Arnshay says the block has a mass of less, so it's a no. Show how you decide. Well, 5.25 is greater than 5, and that's enough justification to get you full marks. Next one, we're baking cakes. It's basically asking, after all that waffle, what's the smallest difference possible? Well, we've got a 400-gram cake and a 300-gram cake, and their smallest, therefore, difference is 100 grams. But then you look at the other extremes, there's 500 and there's 200. Again, You're subtracting to find the difference, and we're getting the biggest possible difference as 300. That's all it wants. Don't overcomplicate. Number 5, the first real waffly one for me. Okay, and my hint as always, one line at a time. Jenny's mixing some paint to make brown. There's my brown. And she's making orange. She's making orange by mixing red and yellow. Get it organized so you don't have to keep going back. 40% of the orange was red. Now, when you do 40%, this is starting to look like a bit of a probability tree, just vertical instead of horizontal. Never use percentages, fractions all day long. She then mixes the orange paint with some blue paint. So we already had brown. Let's stick in the blue. The blue is the 21 out of 41 shares. Now, if that's the case, then the orange is 20 out of 41. What fraction of the brown paint is red paint? This is where your probability trees come into play. We're going down that branch and we're multiplying it by that branch. 20 over 41 multiplied by 2 over 5. And you can go top times top, bottom times bottom if you want, because it doesn't say you have to cancel your answer down. So 40 over what will be 205 is perfectly correct. Or if you're the sort of people who do pre-cancelling, so divide the top by 5, divide the bottom by 5, and then do top times top, bottom times bottom. Both are correct answers. Doesn't matter which one you prefer. Number 6. As you can see, they've put equilateral triangle in bold. That means all the sides are the same. What does that mean in terms of algebra? It means that the 2x plus 3 on the bottom must equal the 8. So don't worry about the square, we'll come back to that. Let's get this solved. Take away 3 from both sides, and we divide both sides by 2, giving us 5 over 2, or 2.5. We can now take that up to the square, because what do we know about a square? These will be the same. Well, let's move on. It'd be nice. We've got an expression here that involves x's and y's. It'd be nice if we can get rid of the x's. 2.5 times 7x is what we want. 7 5s are 35. 7 2s are 14. And we get 17. As like the previous earlier question, there's one digit after decimal point. We need 1 in our answer, which takes us to this expression. We can replace the 7x with 17.5. Take away 5y. Now we know it's equal to 10. I'm going to add 5y to both sides and take 10 away from both sides. And now we divide both sides by 5. Feel free to bus stop it. Feel free to mental arithmetic. It's entirely up to you. Let's go for a bus stop to make sure. 5 into 7 and 5 into 25. So our value for x was 2.5, and our value for y 1.5, and on we go. Number 7, If you're not sure about your surds like this, think of it as just doing, if you were doing 7x multiplied by 3, you'd get 21x. Same thing, just replace the x with the root 2. We just do 7 times 3, and it's 21, like I say, but replace the x with the root 2. For part B, think about how have we gone from the 2 to the 22. It's been multiplied by 11. It's already been multiplied by root 11. It needs multiplying by root 11 again, so that the root 11s cancel out to give you just normal 11. Number 8. I know students I've worked with don't like the look of these. First of all, it's definitely a non-standard. It's not a quadratic. Don't just assume because there's an x squared or a y squared, it's a quadratic, and you automatically go to 2 brackets. Nope, it's not of the quadratic form. Quadratics have x squareds plus some x's plus a number on the end. There can be no x's in the middle in the case of the difference of 2 squares. So it's not in that specific form. So it is only a 1 bracket job. Because there's lots going on, I tell my students to slow it down and write it out in full. Just don't bother with the multiplication signs. Firstly, do the numbers. What's in common in a 3 and a 6? They're in the 3 times table. And what's the leftovers? Divide that by 3, divide that by 3. We can put the plus 2 in the second term there. Now take out what's in common. There's an x and an x. Comes out. There's a y and a y. Out it comes. Now this way's a long way of doing it, but now you've got all your leftovers. There's a y left over. That's on the first term. There's a 2 and an x left over. That makes your second term, and you're done. Number 9, go on them think backwards puzzles. If I said think of a number, double it, what's your answer? The way you work it backwards is you do the inverse operation. You would divide. Well, just because it's got standard form here, it's still a divide. We need to be working out Hans's number by going 9.6 times 10 to the 8, divide it by 2.4 times 10 to the 5. You need to notice 2.4 or 24 goes into 9.6 exactly. 48, 72. It goes in exactly 4 times, because that's how you divide numbers in standard form without a calculator. Divide your numbers. 9.6 divided by 2.4 is the 4. And when you divide powers, you subtract them. 8 take away 5 gives us 3. You get occasions on these questions where that number 4 it sometimes goes outside the range of 1 to 10, but this case, not a problem. We've got the answer. Number 10, don't care if it's Kate going to London, our focus is on filling in the probability trees. We've got a 0.4 on that branch. In goes 0.6, because every split must add up to 1. But they've not explicitly told us any probabilities here. Normally they tell you 1, and then you've got the rest. The probability that she goes on a train and goes to the theatre is 0.28. Don't forget, when you go down branches, you multiply probabilities. What must we have times 0.4 by, well, 4 sevens are 28, and there we go. Now we can fill in the 0.3 and repeat the 0.7 and the 0.3, and now we can answer part B. Calculate the probability that Kate does not go on the train and does not go to the theatre. Again, it's multiply 0.6 times 0.3. 6 threes are 18. 2 digits follow the decimal point in the question. We need 2 in the answer. Number 11. One of these logical ones, because essentially you can probably tell we need to be multiplying and dividing, but which one at the right time? Let's do it logic, okay? As you can see, going from the top line to the bottom line, there are a third of the pumps. The third of the pumps will mean it's 3 times longer. That's the first problem. But the top line has 8 tanks. We're only wanting to empty 2 of the tanks. A quarter of the work required to be done will mean it's 4 times quicker, or a quarter of the time. Okay, the logic being you can do a quarter of the work, it will only take a quarter of the time. There we go. Now we start with 2 hours. 3 times longer will take us to 6 hours, but we're only doing a quarter of the work. Divide the 6 hours by 4, halve it and halve it for 1.5 hours. Next. Number 12, I've already marked on the centre enlargement. Normally I've pre-drawn these, but I'm not going to do it today. I'm going to take a slightly longer than I normally do. When I do enlargements, I don't get busy with the raise. I do it by counting. Scale factor a half means everything needs halving. What you do is, from the centre, count to a vertex. Usually go with the closest. As you can see, it's 4 to the right, it's 2 up. Halve everything, 2 to the right, 1 up. And you can do that for each vertex if you want. You'll eventually have a posh dot to dot, and there you go. The other alternative is to realise, well, if everything halves, it'll be half as tall. And it's not a rotation. God, that's miles out. That's why I don't do these things live normally. So, yeah, you need it to be 2 squares high because the original was 4. 1 square wide because the original was 2. And carry on, do whatever it takes to fill in the rest. Now's where I get my see-through ruler and I check that everything lines up nicely. Okay, 1 square, 1 bit. Well, that was a bit off, but never mind. You get the idea. I prefer to do the raise as a double check method, not as the way of doing it. Part B, we've got a double transformation going on. Let's do it one step at a time again. Triangle B is reflected. The line y equals 0 is also known as x equals 0 is also known as the y-axis. We just need to make sure that if it's 2 squares to the left, we reflect it 2 squares to the right. Again, like the previous part A, do it by counting. I'm sure a few people are just good at doing it by sight, really. And it says to give triangle C. So get it labelled. There we go. It's triangle C that's rotated around 0, 0. Again, I don't put my hand up for the tracing paper. I do it by counting. The first vertex is 2 to the right, 2 up. If that gets rotated a quarter turn clockwise, it becomes 2 down, 2 to the right. I then think, well, I can tilt my paper, can't I? To make it stand upright, to turn it around, that length of 3 squares is going to be there. So again, I reach for my ruler, and it's 3 squares along becomes 3 squares down. This 2 squares up becomes 2 squares to the right. And fill it in. And obviously you can be rotating your paper to check it, but again, I use tracing paper as a way of double checking it, not to actually form the transformation. Sorry. Draw triangles C and D. We've done them. Oh, should really have stuck a D on there. Describe the single transformation to get B to D. So we need to go from there to there. You could think about flipping it, rotating it, and all that malarkey. I'm afraid it's none of them. It's your old friend. Sure, you've seen them before. As you can see, it's a reflection. Okay, you go from top left to bottom right, tilt your head 45 degrees to the right. You can see it. And when you explain it, you just need to spell it all out. It's a reflection in the line y equals x. They're quite long-winded then. They are worth taking a bit longer over. As you can see, total of 5 marks. I'd say 7 or 8 minutes on that, because Eduqas do give you plenty of time with their 2-hour 15 limit. You should have some to play with under normal circumstances. Number 13, show they are parallel. We need to look at gradients. Neither of them are in the y equals mx plus c form. That's what we're going to do. Left hand side, add our 12x to both sides. Whoops, saying one thing, writing another. Adding 12x takes it to the right hand side, like so. And then dividing everything, every term, divide it by 3. That results in the gradient of the first line to be equal to 4. The right-hand equation is actually a little bit more straightforward. We just divide everything by 2. And again, we've matched the gradients. The gradients are both equal to 4. That's where you get 2 marks from. You now need a statement connecting the 2. And on my original, I've just put same gradient means parallel, or any short word or phrase to that effect will get you the marks. Part B, calculate the coordinates of the turning point. You are more than welcome to complete the square. And if you've done that, if you've used the extra space down the bottom, if you've completed a square on this, the way to do that, by the way, is take out the minus first. And now you can complete the square, or you could factorize it to find the solution, but what's the point in that? Completing the square does indeed find the coordinates of the vertex, which is basically the same thing as the turning point, but there's that extra bit of knowledge. The vertex passes through, sorry, the line of symmetry passes through the vertex, and these graphs are symmetrical. Take the minus 5, add it to 1, you get negative 4, and halve it. You get the value of x to be negative 2. It's where the vertex is, that's the x coordinate. You now need, obviously, the y coordinate, which again, completing a square is usually the most useful way for this, but because they've given us this way of going about it. I'm going to take the -2 and substitute it in. -2 times -4 gives me +8. -2 all squared is +4, but it was a treble negative essentially. It's a takeaway. 5 plus 8, 13. Subtract 4, we get 9. And again, if you want to practice completing the square, go for it. 14a looks quite strange, but easier than you might think. Find the next term. Ask yourself, what's going on the top? It's multiplying by 5. So you could mental arithmetic it. Either way, 600 times 5 is 3,000. 25 times 5 is 3,125 on the top. What's happening on the bottom? It's doubling, so double it again. And as you can see, the signs are alternating. It's gone plus, minus, so leave it alone as a plus. Fibonacci, 10 plus 15 makes 25, and so on. So your job is only to do 40 plus 65. That's why it's only worth 1 mark. Part B, we need to do 10 root 5. It says calculate the fourth term. That means n equals 4. How do you do something to the power of 4? I would say square it first, and then square it again. So go power of 2 first, and then go power of 2 again. 10 squared is 100. Root 5 times root 5 is 5. So in the brackets, I've got 500, but we still need to square it. 5 5s are 25. 2 zeros and 2 more zeros give us 4 zeros. On to part C, finding the nth term. Differences. It goes up by 12, 20, 28, and 36. And you start to see a pattern. Goes up by 8, 8, 8. So we have a common difference on the second difference. That means we are dealing with an n squared. You halve this second difference. It's a 4n squared sequence. You can now sack that off. 4n squared is algebra 4, the square numbers multiplied by 4. So 1 times 4, 4 4s, 9 4s, and we're on 64 and 100, and it now becomes a little bit more obvious. It's down by 1. Minus 1, job done. To number 15. I'll do this the long way. No, normally I just say on these, oh, I've already done it. This one, let's do it live. 5 times 6, this is the AC method. 5 times 6 means we're aiming for two numbers which multiply together to make 30, adding together to make 13. Bit more obvious than they normally are, I must admit. But there's my key step. Create a little bit of room. So, hopefully you've spotted it's a 10 and a 3. I've put the 10 with the 5 because it's a better pairing and the 3 with the 6, but if you put them the other way around, it doesn't matter. But don't forget, when you split the 13 into 10 and 3, it's 13x, which is being split. And on we go. Now we factorise the left-hand side. There's a 5 and an x in common. On the right-hand side, there's just a 3 in common. And if you're doing it right, you are hoping that these brackets are the same. Let's see. 5x times x gives me 5x squared, and 5x times 2 gives me the 10x. 3 times x gives me 3x. 3 times 2 gives me 6. I'm definitely correct. I'm confident things are going okay. The repeated bracket is one of the brackets. The leftovers is the other. On to part B. As always with these waffly explained ones, I've explained it fully on my model answers. Feel free to go to the site and check them out. What's Adrian done wrong? It's right at that final stage. Remember, folks, when you are multiplying or dividing by a negative, that must reverse the inequality. So it doesn't matter whether you're timesing or dividing, the inequality should be reversed. It says Adrian's method is incorrect. Explain why. And again, a good way of explaining how someone's done something incorrectly is to do it correctly. X should have been less than -2 is the way he should have been looking at it. And question C, they've gone for a full-blown laws of indices question. On the top, you have power to a power. That's the situation where you multiply the powers. That's your first step done. And finally, over means divide. Divide means subtract the powers. Not a bad 2 marker at this stage. Next one, do not get put off with vectors. You might not like the grade 8, grade 9 doolally proof type vectors, but this is not that kind. We are adding them together. You could do it diagrammatically, or you could do it algebraically. I'll do the algebra. When you are adding 2 vectors together, you just add the elements which are corresponding, so the tops and then the bottoms. 7 added to -2 is 5. -2 plus 4 gives us 2. So you need a starting point. Pick anywhere on the grid that won't cause you to go off the grid. And once you've picked a starting point, you need to go 5 along. 1, 2, 3, 4, 5, and 2 up. Job not finished yet. Not only should you join them, but a very important step in vectors is, as it stands, there's potentially 2 vectors on here. There's the left to right and right to left. Do make sure you put a direction of travel on there. Put an arrow on your diagram to signify the direction. Speaking of those horrible doolallies, though, they've brought it in for part B. For me, the key step, the key bit of waffle, is these are in the ratio of 2 to 3. Whatever that is, that's 2 shares, that's 3 shares. Well, first of all, let's do, if they're telling us W to Y is 2 of the shares, let's just find out W to Y. We need to go with the 6A and against the 4B. So that must be a subtract. It'd be nice to go to the whole line. So let's halve that. Let's find out what one part is worth by dividing it by 2. If that's what one part of this vector is, well, if they're in the ratio of 2 to 3, there's 5 parts. W to Z is 3A times 5 and negative 2b times 5. Given that wy to yz, write the vector wz in that form. Well, we're done. Easier than those other doolally ones. I know some people won't like that, but easier than the average is the best way to put it. We've got fractional indices. I'll always stand by the top number makes it bigger, the bottom number makes it smaller, and if you haven't got a calculator, you're never going to make it bigger first. So let's cube root of 8 is 2. Now get your fingers working. 2 times 2 times 2 times 2 times 2, 32. Part B, write it in the following form, or in other words, rationalise. Multiply top and bottom by root 2. When you're multiplying fractions, it's top times top. Bottom times bottom, you could write root 4, but why would you when you know root 4 is 2? And don't forget to keep an eye on the answer that they want, the form they wanted it in. It needs simplifying for 3 root 2. Question C, they've put it in bold. Estimate. What we'll do is we'll call the 1.96 2. We'll call the 6.89 7. Now, if you did write it out in full, power of 8, by the way, is hundreds of millions. Okay, powers of 6 millions, powers of 9 billions. But the thing is, when they're of the same kind, they are very easy to add. If you want to do 3 million plus 4 million, it's just 7 million. You just basically add the numbers. So adding 200 million to 700 million, it's 900 million. Now on the bottom, we've got the number 300. Another way of writing the number 300 is 3 times 100, but I'm writing the 100 as 10 squared, and weirdly, we had one of these earlier on. We're dividing two numbers in standard form. 9 divided by 3, and just like earlier, we minus the powers of 6, or in this case millions, but it wants the answer, leaving in standard form, not writing as an ordinary number. Number 18, as soon as you see 6 marks, you know there's going to be a lot of work going in. But these two-way tables, they're normally quite friendly, as long as you do one thing at a time. And this one's no exception. It is still quite friendly, except there are some calculations to do along the way. The main rule being one thing at a time. Lena sold 200 drinks. That's already on the diagram, so we don't care. The table shows, so nothing new up here. Forget it. On the Saturday, 15% were large teas. Well, 10% is 20. Halve it for 5%. That tells us that 15% is 20 plus 10. 30 are large teas. Doesn't give us any more to fill in, I'm afraid. The ratio of the number of medium teas to the number of medium milkshakes sold is 3 to 1. So medium teas to milkshakes sold. So we've got medium teas in here to medium milkshakes in here is in the ratio of 3 to 1. Well, hold on. The 3 is just 3 times bigger. we can just slot in an 18. Once we've pieced it together, it's multiplied by 3. Now we can fill in this left-hand column. 5 plus 18 plus 30 gives us a 53, but also now we can fill in this middle column. Feel free to do a takeaway if you wish. This is where I'll just do it quicker because I've already done it on my worked answers. For 81, the number of large milkshakes sold was double the number of small. So small is an unknown number. Large is twice as many. That means we can say that these 3 x's added to the mediums gives us the total number. Well, take away 6 from both sides and divide by 3. We know that there's 20 small milkshakes, 40 large milkshakes, and that does now allow us to fill in the rest of the table. So let's read along the large. 30 plus 42 plus 40 is 112. 200 minus 112 minus 61 is 27. 61 take away 20, take away 5, 36. 36 plus 42 is 78. We need 3 in there to make 81. And always double check. That was the final column I filled in. Check the final row. 18 plus 3 plus 6 does indeed give 27. I know I'm right. But not finished. The probability of selecting a medium tea or a medium coffee. There are 18 in the medium teas. There are 3 in the medium coffees, so 21 in total out of the 200 possible. Again, pretty long-winded. Do not read these questions as a whole. They'll just put you off from actually getting your teeth into them. The number work wasn't the worst bit. It was way over the top. Anyway, number 19 is one of them factor tree questions where they've actually done one of the factor trees for you. You just need to do the 504. And as I say, I've done the bus stop on my work solution, so let's just do it a little bit quicker here. It's outside your times tables, so just halve it. 252. Again, you can halve it, you can divide it by 3. I went for 3. I did a little bus stop, and we get 84. And now, a little bit easier, because we're into our times tables. And whenever I get the number 12, I like to speed things up. Nothing wrong with 3 times 2 times 2. And when you find the highest common factor, you might be a Venn diagram drawer, that's absolutely fine. I just multiply what's in common. There's a 2 and a 2 in both lists. There's a 3 and one of the 3s. There's a 3 and another 3. And there's a 7. Oops. They're the only common prime factors. We need to work out what these are. 2 times 3 is 6. 3 times 7 is 21. I did it that way to make it easier for mental arithmetic. 126. Part B, strange little tack on. What is the smallest whole number that can be divided to give a square number? Well, I've scribbled a bit of it out. It was 2 times 3 to the 4 times 7. Now 3 to the 4 is a square number. It's 81. But in order to be anything else, you would need 2 squared or 7 squared. So they are what's preventing it from being a square number. It needs dividing by 2 and 7. It needs dividing by 14. Number 20. Again, like I always do with these, I have written them out in full, as I would expect if I was doing the exam myself. Done it all in full. Not going to do it again here. I'll just talk you through the reasons. It's up to you to put it in your own words. I'll give you the suggestions. Firstly, notice that XO and ZO, Z0, whatever you call it, they are the radii. So they are the same, but what does that mean? It means that we have base angles of an isosceles triangle are equal, which it allows us to find out that O is 112. Okay, so base angles of an isosceles triangle are equal, or any words to that effect. You might say it's isosceles, so there are 2 lots of 34, meaning angle XOZ is 112. Anything, because the mark schemes for these, they're more generous than you think they are. It simply says, and I've read it, feel free to go and check it yourself. They simply say gives two circle theorem reasons and so on. They occasionally look for keywords. What do I mean by keywords? Well, let's look at the next step. To get the final answer, we do 112 halved to get 56. So 56 is the correct answer. That's why Maya's done it incorrectly. But why is it 56? Because the angle at the centre is twice the angle on the arc. So they're looking for words like centre and arc, or if you didn't use arc, the word circumference. Angle at the circumference is half the angle at the centre. Words to that effect will mean you're picking up the full 4 marks. Number 21. What a lot of waffle for just a 1 marker. Bonkers. But there we go. What's Alice done? What can we criticise? Well, as you can see, 1, 2, 3, 4, 5, 6 bars. 1, 2, 3, 4. Whenever you group data together, it loses some information. All right. So the fact that she's grouped those two together to be 0 to 100, because the bars could have been more like that. So you could potentially be losing the mode. We don't know what the mode is now she's grouped them together. It's a lot more difficult to tell anyway, whether you lose it or not. And she's done the same up here. That could be the mode. One of these bars could be up there, one could be down there. So whenever you group data, you lose a bit of accuracy, you lose a bit of information. It's not like there's 500 bars. Why would you group them together? It's not that much of a pain to draw 6 bars on a histogram. So, one criticism of Alice's histogram, by grouping, some data has been lost. But again, just for the 1 mark, you don't have to waffle 3 lines to get that mark. Part B though, we're going to do it properly this time. Again, the 2 to 300 is missing. Problem is though, what we don't know is how many students need to be in that bar. Well, firstly, we need to work out the areas of all the other bars, because area means frequency. This first bar is 100 times the height of 0.18. That means there are 18 students in there. Second bar is 0.4 times 50. That means there are 20 students in there. 0.2 is the height times 50 again. Means there's 10 in there. There's 12 in this bar, that's 100. times 0.12 and 100 times 0.1. As you can see, 18 plus 20 plus 10 plus 12 plus 10 means there are 70 students accounted for. We need 30 students in this final bar. Its width is 100. Area divided by width gives you the height you need to draw. Get your ruler. I'm slightly out. I'll nudge it up. This is why me and technology, yeah, not the greatest. There we go. Don't need to go exactly to the bottom. Oh, terrible. But you know what I mean. That'll do the job. There's our bar at the correct height of 0.3. Next bit, make a comparison between the amount and what you can tell if you compare the two. The year 11 students, it's kind of more skewed towards the right hand side, towards the greater times, whereas the year 7s, there's more skewed towards the left and it kind of drops off above 300, whereas here keeps quite solid. Again, it's only worth 1 mark. Just keep it simple. I've put year 11 students spend more time on their phones than year 7 students. That's it. That's all you need. Don't overcomplicate. Don't over waffle. Number 22. Speaking of don'ts, don't get put off by topics like iteration. It is just repeated substitution. This waffling here simply means to get the next value times the previous value by 1.2. And that's it. After day 1, we need to times the previous amount, which is 1,000, by 1.2. And that's it. 1,200. Job done. Use this formula to do 3 days. Well, before we do 3 days, we need to do 2 days. We need to do 1,200 times by 1.2. Well, 12 12s are 144. The answers are in the thousands. It's going to stay in the thousands. B3, that's a hell of a 3. 1440 times in by 1.2 again. You may already know that 144 times 12 is 1,728. I say you may already know that because 12 cubed, that's what 1728 is. If you're familiar with your cube numbers, it's a familiar number. If not, do your own technique, multiply it properly, but 1,728 is the correct answer for your 3 marks. Do not get put off by iteration. It's not as bad as you may think it is if you're not a fan. Next, we're stacking blocks on top of each other. We are basically stacking these colours on top. That means the first one has 5 possibilities, then it's 4, then it's 3. And these are multiplied just like those questions I'm sure you've done for your revision. Options, permutations, combinations on them. What am I doing? I'm looking at something else. 5 times 4 is 20, obviously. Times 3 is 60. No one noticed the mistake, Al. How many arrangements are there where the middle block is either blue or red? Let's just have a think about it. There's our blocks. It's just easier to draw circles than blocks. We've got the situation where the middle block, we want it to be blue. So blue is only one possibility, but we could also want it to be red. They're going to be fixed. The question is, what else could be happening? If we assume that blue must be fixed, That means there are 4 and 3 possibilities for top and bottom, and 4 and 3 possibilities, don't matter about the order, because at the end of the day, we are multiplying them. So with blue in the middle, there are 12. With red in the middle, there are also 12, which makes 24 different things, different arrangements are possible. Number 24, I've definitely cheated here because I will get it massively incorrect. Obviously, the strips are for part B. Calculate an estimate of the acceleration at 8 seconds. You need a tangent at 8 seconds. I'll also stress the mark scheme does not actually specifically give an answer. It simply allows follow through from the candidate's diagram. So just make sure you don't draw it so it's rubbish. I've drawn it such that, as you may see, it starts at 4 seconds and finishes at 12 seconds, which means I don't need to guess at how wide it is. I just need to guess at its height, which happens to be 11 for me. But for you, you might have a slightly larger, slightly smaller triangle, but I would recommend that size. I wouldn't recommend any smaller. Bigger's fine. Smaller, I wouldn't. Now, when you're finding out the acceleration, you need to do the vertical distance, the height of your triangle, divided by the width of your triangle. And again, by keeping mine on the whole numbers of 4 and 12, it means this number's quite easy. 11 divided by 8 is 1 3/8. And that's all they need. The mark scheme does not specify a particular number. It just allows follow through from your diagram, as long as you've done changing y's divided by changing x's. And it doesn't matter, they don't care whether you've given it as a fraction or a decimal. They truly are not that bothered. And on to part B. Now for part B, that's why I've split it in, because it's the old question, estimating the area under a curve, and it says to use 5 vertical strips equal width. That's why I've chopped them up. You might do the old thing of calling them A, B, C, D, E. Examiners aren't really bothered how you get to the final answer. We do have the weird situation here where the final trapezium, shall we call it, is actually a rectangle. But the most important bit of information is the heights of these things. So just make sure the numbers I'm going to be using, I read that height as being 16. The next one as being at 24. The next one for me goes through 28. And these final two both are at 30. Let's crack on, do the calculations. So A was simply a triangle. It's a half base times height, so a half. The base was 4, the height was 16, so the area is 2 times 16, 32. For B, I'm going to give up on saying a half of the distance between them because it's a half multiplied by 4 in each case. So I'm simply going to sack that off and write it as 2 times. So I'm combining the half and the height. So actually the only bit I need to do is add together the parallel sides. It was 16 and 24, 24, 28, 28 and 30, and it was 30 and 30 for the rectangle, but I've still treated it like it was a trapezium. I get 80 for that, 104 there, 116, whoops, and 120. And when I added them up, I did them in pairs. 112, 220, and column addition gives me 452 metres. Didn't seem to be any leeway, strangely, on the mark scheme. Just make sure you do show you're working out, and you should be fine. Question 25, inverse functions. Show that h to the minus 1. Well, let's find h to the minus 1. Let y equal the function. I'm going to subtract 3 from both sides and square root both sides. If you've put plus and minus there, that's fine. No one cares, because the inverse function, the only bit the examiner cares about is that you then stick the x back in. I'm sure your teacher tells you just to flip around your x's and the y's. But you need a bit more than that. You've earned 2 marks so far. The mark scheme requires a bit of explanation. And that explanation will be something along the lines of, you cannot square root a negative. Okay, so, or words to the effect that the minimum value of x is 3. We can't have x as being any smaller, and so on. Part B, quite a lot for this one for me. You've got the f of g of x and the g of f of x. What do they mean? It means, for the first bit, the g of x needs to go into the f of x. The f of x was x squared. The x squared becomes x minus 4 squared. And we haven't touched the plus 5. We need to subtract the g of f of x. That means that the f of x needs to go into there. We'll be getting x squared and the 5, but take away 4. But I will just say there's a minus in front of it. The minus in front of the g of f of x means the whole lot is multiplied by -1. We can tidy it up on the next line whilst we multiply out these brackets. We're squaring a bracket, so we square the first, square the last, times the 2 together and double it. We have a plus 5, and we now can expand these brackets. -1 times x squared. They cancel. Inside the brackets, BIDMAS 5 minus 4 is 1. Positive 1 times -1 is -1. Now, just because I don't like to jump straight to the answer, I am going to just put these numbers next to each other first before I simplify. Show means do, and hope you get the same answer, and we did. Number 26. Slightly non-standard for these because the e's are on different sides. Normally they're all over the place, but anyway, you get rid of the square root by squaring both sides. 3e times 3e is 9e squared. The right-hand side, it disappears. I'm going to get the e squareds, the e's, to the left-hand side. I'm going to add a de squared to both sides. If you chose to take away, I think that's the wrong choice. It's a bit harder. It just means your answer will look like my answer, but where the positives are, you'll see a negative, and vice versa. If you want to make e the subject, you need to take an e out normally. But first, we're going to take an e squared out. That would leave us with a 9 and a d. Now we can divide both sides by the brackets. And a lot of the times, you're actually finished. But there's one more bit to go. Square root both sides to make either subject. And when you square root, I think you should put the plus and minus on, because it means you're alert all the time anyway. I forget what the mark scheme says, if I'm honest. You'll need to look it up. Number 27, good old recurring decimals. Let x equal the decimal. And I like to create a little bit of room if I remember to do so. Now the recurring dot is not above the 3. Let's budge it up, because what you want in these questions is you want the recurring dots to fill up all the space after the decimal points. And you want to do it again. To do it again, we need to budge them up so it becomes 345.45. How do we budge them up? Well, to go from 3 to 300, we've times both sides by 100. 10 times 100, we get 1,000. We now have the recurrings after the decimal points, such that when we subtract, they will disappear. 1000x, take away 10x. 345, take away 3. And the 0.45 recurrings minus the 0.45 recurrings, they disappear. It does not tell us to leave our answer in its simplest form. So you can simply divide the 342 by 990 and you can stop right there. If you've cancelled it down, you've got too much time on your hands. Finally, number 28 looks horrendous. Usual Eduqas rubbish clip art. I'm a big hater of their clip art. But what do we care about is the information that's on the graph. What you can see is at 5 seconds, the speed is 12. At 10 seconds, the speed is unknown. But what we are told is the gradient of the line. Gradient of a line when it's meters, when it's distance and time, when it's speed and time, the gradient is given. The gradient means acceleration, or in this case, deceleration. But let's drill down into what gradient means. The fundamental meaning of gradient, the letter M means for every 1 unit to the right, you go up and down the amount. So for every 1 unit to the right, this graph is going down 1.5. Well, this doesn't go along 1 unit, it goes along 5 units, which means it's going to go down 5 lots of 1.5. It's going to go down 7.5, and down from 12, we take away 7.5, the dog ends up at 4.5 meters per second. Okay, that's the speed at 10 seconds. Quite a strange one. There's other ways of doing it. You could use equations. For me, why would you bother? It's knowing that the fundamental meaning of gradient is for every unit across. That's how much a graph goes up or down. Anyway, quite a long one that. What we at? Hour 10 or so. Long paper. Must have been on the trickier side, or maybe I'm just slow this morning. But anyway, I hope that's helped, and I'll see you maybe on paper 2, component 2, sorry, the calculator paper. Let's see.